Good morning, student. Next term, Gibbs free energy, symbol C. One of the important applications of second law of thermodynamics is predict spontaneously reaction under a specific set of conditions. The reaction that occur under a given set of conditions without any external driving force called spontaneous reactions. Spontaneous reaction means, for example, rainfall. The otherwise is said to be called non-spontaneous. In our day-to-day life, example you see. First example, waterfall run downhill but never uphill spontaneously. The lump of sugar dissolved spontaneously in cup of coffee but never reappears original form of spontaneously. After mixing of coffee, no prepare for sugars. Heat flow from the hotter object to colder one but never flow from colder to hotter object spontaneously. The external force will be applied. The expansion of gas into the evaluated bump into a spontaneous process. Irreversible is that gathering all molecules in one pump is not spontaneous. For example, spontaneous reactions. There are here having a number of molecules. That opening means the molecule come to another bulb. Non-spontaneous is impossible. Non-spontaneous are impossible. The above examples all are showing spontaneously one direction cannot take place in opposite direction in spontaneously. Similar reaction, methane react with water molecules gives carbon dioxide plus water molecule will be given. And delta H enthalpy value minus 890.4 kilojoule mole inverse. Another example, acid base neutralization. H plus acid, OH minus base gives water molecule. Delta H value already you know, minus 57.32 kilojoule mole inverse. Another reaction, ammonium nitrate NH4 NO3 hydrolysis used ammonium plus NO3 minus. In this reaction, delta H value plus 25 kilojoule mole inverse. Next up, in second law of thermodynamics introduced another thermodynamic function is called Gibbs free energy. Gibbs free energy was developed in 1870s. Joseph Willard Gibbs. Gibbs only developed. The original term this energy is called available energy. Available energy. And to work in the system, the quantity of the energy associated chemical reaction used to defined as G is equal to H minus Ts. This is for first equation. G is called Gibbs free energy. H is called enthalpy. T is called temperature. S is called entropy. Let us consider for them from state 1 to state 2. That means G2 minus G1 equal to H2 minus H1 minus temperature S2 minus S1. So G2 minus G1 equal to delta G. Here delta H minus D delta S. Equation number 2. Now consider delta G is the spontaneous. So del S total equal to del S system plus del S surroundings. For reversible process in equilibrium means that universe is the zero. So del S total equal to 0. Similarly, del S 0 means you apply the equation 2 means del G also 0. Spontaneous reaction del S total greater than 0. That means del S system and del S surroundings greater than 0. That means del H system divided by temperature equal to not equal to negative minus del S system greater than 0. So del H system minus d delta S system greater than 0. Otherwise, d delta S system minus del H system less than 0. For a hence spontaneous process del G less than 0. That means del H minus d delta S less than 0. Equation number 3 at time. Spontaneous process means del G less than 0. Non-spontaneous process means del G greater than 0. Next, Gibbs free energy network done by the system. Apply them all at constant pressure and temperature. Del G is equal to del H plus minus d delta S. Equation number 1. Now del H equal to del U plus B delta V. P delta V. You apply the formula. Del U plus B delta V minus D delta S. First law of thermodynamics, del U equal to Q plus W. Next, del S equal to Q by T. So, T delta S equal to Q. You apply the del U value and T delta S. So, del U replaced by Q plus W plus P delta V minus T Q by T. Del S value Q by T. So, plus Q and minus Q cancel. Remaining T cancel. Remaining W plus B delta V. You change the work will be negative means minus del G. Sign will be changed. All the sign will be changed. Positive here negative. Negative work minus P delta V. That is equation number 2. Equation number 2. But B delta minus B delta V represent work done to expansion against a constant external pressure. Therefore, clear that decreasing the free energy. Negative means decreasing the free energy. The system other than work of expansions. Work of expansions. Next, criteria. Del H value negative means reaction process is the exothermic and reaction is the spontaneous. Reaction is the spontaneous. Del H value positive means endothermic and may occur the spontaneously. May occur the spontaneously. Next, effect of temperature and spontaneously of reactions. First column del H R, del S R, del H R equal to del H R minus d delta S R. Descriptions example. First, negative positive at all temperatures, spontaneous for all temperature. Reactions in ozone converted to oxygens. Ozone converted to oxygens. Second, negative to negative means two different temperatures. One is the at low temperature, one is the high temperature. Spontaneous at low temperature, here non-spontaneous at high temperature. Absorption of gases. Next, positive to positive means at low temperature also possible and high temperature. Positive means non-spontaneous low temperature. Negative means spontaneous and melting of solids, any solids. Positive, negative at all temperature, non-spontaneous at all temperatures. Water plus water react with oxygen means H2O2 is given. H2O2 is called hydrogen peroxide. Next topic, relationship between standard free energy and equilibrium constant K equilibrium. Let us consider reversible process. Let us consider reversible process. In reversible process means reversible chemical reaction proceed in either directions simultaneously. For example, A plus B reactant is given C plus D. C plus D product also given A plus B reactant. The free energy change in delta G related to them delta G degree. Delta G is equal to delta G degree plus RT T log in Q. Equation number 1. Q is the reaction quotient. Reaction quotient. Defined ratio of concentration product and divided by the reactant under non-equilibrium conditions. That means del G is equal to degree minus RT log in K equilibrium. These for equation 1 of equations. 1 of equations. Del G is equal to del G degree is equal to you replace the log in means minus 2.303 RT log of K equilibrium. Equation number 2. We know also that del G is equal to degree equal to del H degree minus d delta S degree. That means minus RT log in K equilibrium. That is del G degree values. Next, third law of thermodynamics. Absolute 0 Kelvin or minus 273 Kelvin. Theoretically, all modes of motion stop. Absolute 0 is temperature object can get orbitally close to, but absolute 0 will remaining unattainables. Now another statement for the law of thermodynamics: entropy pure crystalline substance absolute 0 is 0. Otherwise started the impossible to lower temperature and object absolutely pseudo fine number of steps. Mathematically limits temperature absolute 0 and entropy also 0. Next lesson, you need to quantum mechanical model of atoms. The radical crystal development of atomic models made up of are made up of matters only. Made up of matters only. The basic unit that can be all made up of matter means inside atom only presence. The atom is derived from Greek word atomio. That means non-divisibles, meaning non-divisible in Greek word. All are made up of matter. Matter inside atom only present. In Greek word, atoms non-divisibles. Who is first discovered means subatomic particles, electron, proton, and neutron. First, who and explain means J.J. Thomson will be explains. That explain for cathode rays. This called for negative charge particle is called electrons. Negative charge particle called electrons. The electron unfold like seeds from watermelons. The latter is explained Rutherford alpha ray scattering experiment. Most of the alpha particles passed through the foil. Next, some of them were diffract through the small angles. Very few alpha particles were reflected back to 180 degrees Celsius. This reflected, that is the screen wave. Rutherford alpha ray scattering experiment. He proposed that atom the tiny positive charge nucleus and electron moving around the nucleus. Electron moving around the nucleus with high speed. The theory of electromagnetic radiation said the moving charge particles should continuously losses of the energy in from radiations. The moving electron should continuously lose the energies. Continuously lose the energies. So collapse of the atom. That does not happen and the atom will be more or stable. So come another scientist Bohr atom models. Bohr atom models. The Bohr atom models energy of electromagnetic radiations H nu equal to H means Planck constant. H means Planck constant, nu means frequency. The H constant, Planck constant value is 6.626 into 10 to the power of minus 34 joule seconds. Extent of Planck quantum hypothesis of the energy of atom, Niels Bohr only explains. Niels Bohr only explain. The first point, the energy of electron is quantized. The electron revolving around the nucleus certain fixed circular path is called stationary orbit. Electron can remove only this orbital angular momentum. Angular momentum means mvr. M is the mass, v is the velocity, r is the radius, equal to nh by 2 pi. N is the number of atoms, n equal to 1, 2, 3. H is called Planck constant, already you know. Planck constant value 6.626 into 10 to the power minus 34 joule second. As long electron revolves in the fixed stationary band, does not lose its energy. When an electron jump from higher energy state, that means 1s to 2s, 3s, 4s energy to at lower energy state E1. Excess of energy emitted radiation, the frequency of emitted radiation E2 minus E1 equal to H nu, otherwise is called nu is equal to E2 minus E1 divided by H.